What did we say yesterday about the median and the centroid? What are we going to do with that line right there? Cut it into thirds. So the centroid down to the side is at 1/3, and then from the vertex to the centroid is the 2/3. So how do you divide 5? Because it said A to D was 5. So what is each section? Or no, what's this 5 divided by 3? It's 5/3. It's gonna repeat, right? Anything divided by most things divided by 3 is gonna divide. So this is really 5/3. 5/3. It's a decimal, whatever that is. 5/4. Yeah, let's see that now. Thought about that. I was counting. So, and they tell you round to the nearest hundred. So from that, what can we answer? All right. So it asks you what's the length of O to D. So O to D is just this piece right here, and they say round to the nearest hundredth. What's 5 divided by 3? I don't know, 1.6. And that's all you do. Now the other one, they say E to O is 4.2. So what part of E to O? Because now this is this median. So E to O, I'm dividing into thirds. That's the 1/3. The other is the 2/3. Okay? So it tells you E to O is 4.2. Well, do I need to divide 4.2 into thirds? No, it gave me the 1/3. So what is this little piece from here to here? 4.2. What about this piece here to here? 4.2. Now, when it asks you whatever question, what's B to E? Oh, where is B to E? They want to know the whole thing. So now that piece, 4.2 times 3. I think this may be one I used an example yesterday. For a 12.6. Yes. Breaking them into thirds is a big deal. We're good? Centroid, medians, numbers. Go on to number 12. There's a triangle. Only thing I remember about the triangle is this J at the top. What are the other letters? Is this M?
K is right there. M in the middle.
K, M, and then L? All right, and that's kind of how it's drawn in your book, number 12. Okay? And it wants you to prove, it says, using the diagram shown, prove Km is congruent to or is equal to Lm. So what do we need to do? Did you do a proof?
The first step, I put Km, 1 Km equal to Lm.
Do you know that? Read the sentence. If you just read the sentence, it says, using the diagram shown, prove Km equals Lm. They don't tell you that's true. They say prove it. So how do we know what's given to us? It didn't give us given and prove. They gave us a diagram, and what's in the diagram? When you see these little arc marks, is that the information given to you?
Yes.
This little right angle mark, is that given to you?
Yes.
So should that be our first statement? Our statements and reasons. So first, we're really given, what do we need to say? Let's say angle KJM is congruent to angle LJM. How do we know that?
It's good.
It's good. know? What else was given to us? Angle LMJ is congruent, which technically they didn't tell us they were congruent. What did they tell us? They're right angles. So LMJ and angle KMJ are right angles. That's number 2. If you want to write those two together, because they're both given, they tell us that they're right angles. They don't technically tell us that they're congruent. Okay? But what do you know about every right angle? Every right angle has to be congruent. Is there a theorem about that? Yes, there is. What, does it have a name? Right angles congruent. This is all right angles must be congruent. So what do we have so far? Our line 1 gives us an angle that's congruent. Our line 3 gives us an angle congruent. Can we prove 2 triangles congruent by just 2 angles? No. What else do we need? Another side. So we have an angle here, an angle there. What would be really helpful to have right in between them? Every time they share a side, that side is going to be in both triangles. You're going to have to use that statement. JM is congruent to JM. How do you know that? The reflexive property. So now we have an angle, a side, and an angle. What do you know about the triangles? There. Because of the angle, side, angle. So now I can go over to triangle. LMJ. I'm just copying what I use for when I told angles, because that will be the same order. The angle, side, angle theorem. Are we done? Is that what we tried to prove? Is that what it said we needed to prove? No, they want this thing at the bottom. K to M and M to L. They want to know those 2 side lengths are equal to each other. What do we do? What do you know? If we have congruent triangles, are all of their corresponding parts going to be congruent? Yes. KM is congruent to LM, or however they said it. How do we know? Corresponding parts of congruent triangles are congruent. CTC. Not too bad. You're going to see these a lot where they share a side. Okay? You're going to see those a lot. It's probably going to give you 2 angles, and you're going to have to prove that 3rd side, which is always going to be the reflexive property. Okay? Are we good? Somewhat? All right, can I take your homework up? And we'll begin lesson 33. Lesson 33 is simply the converse of the Pythagorean theorem. What does it mean to be a converse? The what? What does it mean to have a converse. What is it? What is a converse? Opposite, flipped. What is the opposite? What is flipped? Two sides of the equal sign. Okay. Okay, let me ask again. If I give you a conditional statement, if it is raining, I will bring an umbrella to school. What's the converse of that statement? If I bring an umbrella, then it is raining. So it's the if and then, the hypothesis and the conclusion that we switch. Okay? If you look up the Pythagorean theorem, I know what you want to say to me. Okay? But what does the Pythagorean theorem actually say? Don't say what I want you to. Don't say the quick and easy.
The two legs squared added together equals the hypotenuse squared.
Okay, the legs squared, the sum of the legs squared equals the hypotenuse squared. That's much more in there. Is there an if and then?
If the hypotenuse is shorter than the legs, it's false.
If the legs are squared and added together, then the hypotenuse squared will equal the same amount.
Let's look it up. Let's look it up. I think it's in like lesson 8. Or look in the back. It's 8-1. Oh my gosh, why do I know that? Lesson 8. I think it's theorem 8-1.
Sum of the squares of the legs and the
There's no if? Seriously? Sorry, I apparently read something completely different then. Okay, never mind.
The sum of the squares of the legs A and B of a right triangle is equal to the square of the hypotenuse.
And it's written A squared plus B squared equals C squared. Apparently I've lived a lie for so many years. I thought it said if. If it's a right triangle, then. Because that's what the converse says. But can you use the Pythagorean theorem with anything other than a right triangle? Well, it does say a right triangle in that, right?
No.
Yes, it does. Read it again. It does. Okay. If. Oh, that's bothering me now. Now I'm not going to be able to say this the whole rest of the day. Because maybe I just went from, I read this one, and I was like, oh, then the regular one said, if it's a right triangle, then the sum of the lengths of the legs squared is equal to the hypotenuse squared. Because in the converse, it's the opposite, right? Because the converse says, if the sum of the lengths of the squares equals the hypotenuse squared, then it's a right triangle. Everything I've thought about. Okay, never mind. Let's turn to page 212 so we can read the real thing.
But is that like, you've been teaching it that way for like ever?
Well, yeah. I mean, I don't know. Surely I have. I don't remember. When you do stuff and you don't even think about it, obviously that's what I've been doing. But you can't use the Pythagorean theorem if it's not a right triangle. So it makes sense, and every kid believes me. Because it's true. And it says it's just not those exact words. So on page 212, when we read theorem 33-1, it says, if the sum of the squares of the two shorter sides of a triangle is equal to the square of the longest side of the triangle, then the triangle is a right triangle. They don't even use the words legs and hypotenuse, right? Because legs and hypotenuses are only in right triangles, okay? This says if A squared plus B squared equals C squared, then it's a right triangle. The general rule. Okay, so can we use this to say, hey, do these three form a right triangle? Yes or no? Okay, so if I give you something like, well, I don't even have to tell you A, B, and C. It just says the shorter side lengths. So I give you 5, 12, and 14. Do these three side lengths of a triangle form a right triangle? Question mark. So what are we going to do? We're going to pull out our calculators. So, yeah. And then we're going to do what? 5 squared plus 12 squared. Does that equal, I put a question mark above my equal sign usually, equal 14 squared? No. 25 plus 144 does not equal 196. Okay? Ooh, wait just a second. Now, this lesson, we're going to move on and say, oh, if it's not a right triangle, can we determine whether it's an acute triangle or an obtuse triangle? Well, we're gonna go read another theorem, and it's gonna tell us that. Okay, so theorem 33-2 says, well, somebody else read it. I'm talking too much.
In a triangle, let A and B be the lengths of the two shorter sides, and let C be the length of one of the sides. A squared plus B squared is less than C squared, and the triangle is obtuse. If A squared plus B squared is greater than C squared, then the triangle is acute.
So A squared plus B squared is greater than C squared. It's gonna be what?
Acute.
But if A squared plus B squared is less than C squared, it means it will be obtuse. So then I'm actually going to add these two things together and say 169 is less than 196. Okay, so what type of triangle do we have? Obtuse. Okay, this is one theorem that I have to look back at almost every time. If I see it drawn out, it makes a little bit more sense, but if I have numbers, it doesn't make as much sense to me. Okay, yes, they're pushing each other farther apart, so that makes sense that it's going to be obtuse. Okay, when you have those two longer legs that are close to 12 and the 14 are longer, than a lot longer than the 5. Oh, that means it's going to push it more. That makes it more obtuse. But if I just see numbers, I have to go look back at this theorem and say, oh yeah, if it's less than, it's going to be obtuse. If it's greater than, it's going to be acute. It means the numbers are all closer to the same. Okay, does that make a little bit of sense? Mm-hmm. All right.
So then, if we're having the numbers of like an A and a B, and we had to solve for the hypotenuse, could we do that with that kind of equation?
You could. Could I say this? Ooh. If I give you a 5 and a 7, okay? Let me give you A and B. What would the range of hypotenuse be for it to be acute? So I want to give you two side lengths and say, make it acute. So I'm going to go back to that formula that said A squared plus B squared is what? Greater than C squared.
So it would be anywhere from 70.
So here I have 25.
Well, 73.9999.
Okay, wait. 25 plus 49 greater than C squared. So what did you get 73 when you add that? 74? Greater than C squared. Is that what C is going to be?
No.
Do I still have to take the square root?
Yes.
You still have to take the square root to get your side length. So,
More than 8.6.
so, yeah. Is that what you got when you got it out? 8.6 decimals
That's point. Yeah.
But 8.6 out.
greater than C. So C would have to be less than 8.6 for that to be an acute triangle. Okay? So that's a range. So C would have to be less than that. Okay, do you know what a range actually is? It's like you're between two numbers. This is C has to be less than this, but does C have to be greater than anything
It
else?
has to be greater than 0 because you can't have a negative sign.
Do we need to think about that? Yes, because what if I put -4? Is -4 less than 8.6?
Yes.
Yes, it is. It would still satisfy this. So I'm going to put a little star and say,
8.6 is greater than C, which is greater than
I really don't like, I like writing it the other direction, but that's just me. I would put C right here on the other side. Because this doesn't always make sense. 0, C is greater than 0, but less than 8.6. These two things are the exact same thing. How do you read them though? Can you read greater than, less than symbols? Take that for granted. 0 is less than C, which means what? C is greater than 0. Here, C is less than 8.6, or 8.6 is greater than C. Can it equal 8.6 and still be an acute triangle? What happens if it does equal 8.6? Then it becomes a right triangle. Okay? Means we can't have that little equal sign underneath. Okay? Are we okay? Yep, there's a nice application. When they lean things against stuff, but we're just gonna go ahead because I'm so wonderfully nice. I'm gonna assign you homework and let you have the next like 15 minutes to work on it because I said we're doing homework, which I knew we would get through this lesson very quickly. So I assigned it to everybody else. So we're gonna do the practice and numbers 1 through 3, 6 through 8, 11, and 12. Also, we need to write theorems. It's a good time to get caught up on your theorems.